In this video lecture, we are going to discuss about one-dimensional, two-dimensional, and unsteady state heat conduction in radiation heat transfer. So before we go into that, we will know about what is the heat transfer and the numerical methods. Heat transfer means it's a heat transferred from one region to another region due to its temperature difference. So it's a numerical method. It's also one type of a heat transfer phenomena to solve or indicate to incline about the method of the conditions of heat transfer in steady state conduction. So in this one-dimensional, two-dimensional steady state heat take conditions, the heat conduction describes the process of heat transfer due to temperature differences within a material. It can occur in steady or unsteady state and in various dimensions such as one-dimensional and two-dimensional. In one-dimensional heat conduction in steady state heat conduction, the temperature field does not change with the time. For one-dimensional conduction, this occurs along a single spatial directions. And this is the governing equations of one-dimensional heat conduction is d squared T by dx squared equals 0, where T is equal to temperature as a function of position, X is a spatial coordinate, and the solution of a governing equation, the general solution is a linear temperature profile. And T of X is equal to C1x plus C2, and where C1 and C2 are constants determined by boundary conditions. And in unsteady state, in steady state heat conduction, the temperature field varies with both space and time and the governing equations. So dou T by dou is equal to alpha dou square D by dou X square, where T is equal to time, alpha is equal to thermal diffusivity of the problem. And one-dimensional and two-dimensional steady-state heat conduction is two-dimensional heat conduction in steady state. In 2D state, that heat conduction, the temperature does not vary with the time, but changes in two spatial directions and governing equations dou square d by dou x squared plus dou square t by dou y squared equals 0. This is the 2D Laplace equation which can describe steady heat conduction in materials with two-dimensional geometry. And unsteady state, in a two-dimensional unsteady state heat conduction, the temperature varies with the time in both x and y directions. And governing equations dou T by dou T equal to alpha into dou square T by dou x squared plus dou square T by dou s squared. This is the 2D heat conduction which requires both initial and boundary conditions for a complete solution. Analytical solution can be challenging, and numerical methods like the finite difference or finite element methods are often used. So, and the application of the 1D and 2D steady and unsteady state condition is only a steady state heat transfer through a flat wall or a long rod. And 1D unsteady state temperature changes in a rod after a sudden change in environmental condition. And a 2D steady state heat conduction in a rectangular plate with a different boundary condition, example, constant temperature on edges. And a 2D unsteady state heat conduction in a sheet after sudden temperature of change on one side. So this is the summary of one-dimensional and two-dimensional unsteady state heat conduction equation is dou T squared by dou X squared, and Tx x is equal to C1 plus X squared. And these two equations are will explain about the direction of the Cartesian and the cylinder Cartesian coordinates is in a two-dimensional direction with a steady state condition. It's also known as the Laplace equation of this condition. And another is the governing equation is the dou T by dou T equal to alpha dou square T by dou X squared plus dou square T by dou Y squared. This is the 2D heat conduction which requires both initial and boundary conditions for a complete solution. And analytical solutions can be challenging, and numerical methods like finite difference or finite element methods are often used. So is the 1D and 2D steady and unsteady state heat conduction. It's through a flat wall or long rod, and 1D unsteady state temperature change in rod after sudden change in environmental conditions. And the 2D state condition is a rectangular plate with the boundary conditions. And the 2D unsteady state heat conduction in a sheet after a sudden temperature on change on one side. So this is then a video lecture series about one-dimensional and two-dimensional steady and unsteady state heat conduction in heat transfer. Thank you.